The question that I have is, could you do an example involving triaxial CD test data? In this example, we have a CD triaxial test conducted on a normally consolidated clay specimen. It's given that the specimen failed along a clearly defined failure plane of 57 degrees. The cell pressure during the test was 200 kilopascal. The question ought to estimate phi prime, the maximum principal stress ratios, and the deviatoric stress at failure. We established in an earlier video that the failure plane makes an angle of 45 plus phi over 2 horizontal, right? So we set that equal to the given value of 57 degrees, and that gives us a effective friction angle of 24 degrees. So to solve the second part, I'm going to go back to another relationship we derived earlier, which is the relationship relating the horizontal effective stress at failure to the vertical effective stress at failure, which is this equation right here, right? Where sigma 3f prime equals sigma 1f prime times Ka, where Ka is given by this equation minus 2c prime times square root of Ka. This is a normally consolidated clay, and therefore C prime is 0. And therefore we get this expression for the ratio between sigma 1f prime and sigma 3f prime. So the maximum value obviously happens at failure, and that's where we need to find. Alright, so now we have a value for the friction angle phi prime, which is 24 degrees. So you substitute that in here, I get a ratio of 2.37. So to do the third part here, we recognize that the cell pressure is given as 200 kilopascal. So this is a CD test, so there's no pore pressure involved. And this is a standard test. So the sigma 3f is equal to the cell pressure in the beginning, and it remains the same throughout the shearing part. Now we have a ratio between sigma 1f prime and sigma 3f prime, which is 2.37. So using that, we get a value of sigma 3f prime, which works out to be 474. So all we have to do is to subtract one from the other in order to get the maximum deviatoric stress at failure, which is the difference between the two principal stresses. So I get a value of 274 kilopascal.